What's up, guys? In the video today, we're going to discuss the industrial production of ethanol. Alright, so what is ethanol? Ethanol is an organic compound used for a variety of products, including but not limited to a greener fuel alternative to gasoline, medical disinfectants, a polar solvent other than water, and of course the most fun use of ethanol, the adult beverage industry. Ethanol is considered a green fuel alternative not because it doesn't produce CO2, but because the CO2 it produces is consumed by the plants used to make ethanol, so the net emissions are greatly reduced. Also, you're not exploding liquid fossils. Most fuel you use contains a certain percentage of ethanol, usually around 10%, which is indicated on the gas pump. The percentage of ethanol in what you drink, also called the alcohol by volume, or ABV, ranges from 4% to 40% depending on how turnt you plan on getting. So how do you make ethanol? Well, ethanol can be produced in several ways, the most common of which is fermentation. These are what industrial scale fermenters look like. In this process, organisms such as yeast or modified bacteria convert a sugar substrate into ethanol via the fermentation process. Ethanol can also be produced synthetically via the hydration of ethene, which is obtained from petroleum refining. However, since this ethanol is in fact a synthetic product of petroleum, it produces a toxic byproduct, and therefore cannot be used for human consumption. So in other words, not the fun kind of ethanol. Finally, a process was recently discovered that converts CO2 into ethanol. In this process, the CO2 molecules are run over a copper nanoparticle catalyst and converted into ethanol. However, this process cannot yet be replicated on a large scale, and fermentation remains the predominant method of producing ethanol. That being said, ethanol production varies from country to country, but the fermentation conditions are more or less the same, being around 35 degrees Celsius and at a pH of 5. Yeast produces enzymes that break down glucose through a process called glycolysis into pyruvate, which is then further broken down into acetaldehyde and CO2. The acetaldehyde is then oxidized and converted into the final product, ethanol, which is then excreted by the yeast cells. Ethanol is toxic to yeast in high quantities, so it doesn't accumulate in significant concentrations around the yeast cells, so further distillation is needed to obtain a higher percentage of ethanol. This is what a traditional bioreactor looks like. A sugar or starch substrate, usually coming from corn, barley, or some other type of feedstock depending on the cost and type of product desired, is fed to a bioreactor containing a media of yeast, water, and other various nutrients. The bioreactor contains impellers to stir the media, a cold water supply to offset the exothermic process, and sensors to monitor pressure, pH, and temperature. If the temperature gets too high, the enzymes will denature and you'll have to flush the reactor and start again. Now, those of you still paying attention might say, wait, this is a biological process dealing with living cells. Where's the oxygen input? Well, this is because yeast does not need oxygen to grow. Fermentation is an anaerobic process, so it does not use oxygen as a terminal electron acceptor. If all goes well, the yeast produces CO2 and that sweet, sweet ethanol. Most ethanol occurs as a batch process, so the biomass must be removed from the media, which is usually done using one of two methods. Centrifugation uses differences in density to separate the cells from the media. You take the mixture and spin the bejesus out of it so that the denser cells settle to the outside and the less dense cells stay toward the center due to centrifugal forces. The other method that is commonly used is filtration. When the mixture is passed through a filter, the larger cells are prevented from passing through and the media solution containing ethanol flows through. Once the cells are separated from the media, distillation is needed to further purify the solution. This is done by vaporizing the ethanol, which has a lower boiling point than water, and condensing it in a separate container. This creates a solution of about 95% ethanol, which then can be appropriately diluted and used. Alright guys, thanks for watching. Please like, comment, and subscribe, ring that bell to turn on notifications, and a link to merch is in the description below. Go Ram!